Hello everyone, in this video we will derive the equation for the longitudinal stress in case of a thin cylinder. So in case of a thin cylinder, we will derive the equation for the longitudinal stress that I have denoted with sigma L. Okay, sigma L is the equation for the longitudinal stress. So as you can see here, I have got a cylinder, right? This is a thin cylinder, okay? This is a thin cylinder where this is the thickness small t, okay, and the diameter, the internal diameter will be denoted with small d. So from here to here the diameter is small d, and the thickness is already mentioned, and I have got the length of this cylinder is, that is your small l, okay. Which is small l is your length for that entire thin cylinder. So in order to find the longitudinal stress, we know stress is force over cross-sectional area, of course. And what is the force here? What is the force? As we know, that force is going to be equals to the pressure times area, and here pressure is due to the internal fluids passing through it. So this is going to be your P, and the area is going to be the area for the circle, and that is simply pi r square. And of course pressure times pi radius is equals to what? Our diameter is equals to 2 times radius, so radius equals to diameter divided by 2. So I'm gonna end up getting p d by 2 whole square. So this is going to be p into pi by 4 into d square. Okay, so this is the force, and the cross-sectional area, the cross-sectional area is going to be pi dt or 2 pi r dt. Why? Because pi dt 2 pi r into time 2 pi r times t, this is the total area, because 2 pi r is the length of this circumference. You know that for a circle, the entire length from, suppose from point A, if we just groom entirely around it, so you will find 2 pi into r is if the radius of this circle is small r, right? So this is the, in order to find the area, you need the thickness as well with it. So you will find this shaded region, that I have marked it. So this shaded region will resist it from, being torn apart like this, because this is being torn apart of because of the fact that there is a longitudinal stress delta sigma L acting on it. So I will end up getting sigma L is equals to Pt over 4 times T. So this is the equation for the case of a thin cylinder